Okay, then we have here the laboratory test to diagnose someone to have sickle cell anemia. So we have here the solubility test. We have here the use of we have the sodium dithionite test. Other name for your sodium dithionite test or sodium dihydrosulfide. So the reagent for that, we have the saponin, which try to lyse the red cell. And we have the sodium dithionite, which is your reducing agent. So as your saponin try to rupture the red cell, try to release the hemoglobin. In the presence of your sodium dithionite, converts your hemoglobin ion from your ferrous to become ferric. And if you have your sickle cell hemoglobin, so eventually that become converted to your deoxygenated form. And it will be converted here to become your hemoglobin polymer. And then that would eventually become here your, okay, let's try to produce here your turbid solution. So the positive result for that, we have here the turbid solution. The negative result, we have here the clear solution. Okay, we have here the consideration for that. So we have here the false positive result. Okay, so we have in the case of your hyperlipidemia. Then we have also here in the case of your presence of your other cycling hemoglobin variants. Like for example, we have hemoglobin C Harlem, hemoglobin C Georgetown, and we have also here too much blood sample. Okay, false negative result could be seen here in the case of patients less than 6 months old, and we have also here decreased hematocrit results. Okay, another one test here would be your sodium metabisulfite. So the sodium metabisulfite here equivalent to your sodium dithionite is also a reducing agent. So procedure for that, we have here your blood, you put that one in the slide, then you add your sodium metabisulfite, then to try to seal that one with your cover slip with the petroleum jelly on that. So because of that sealing of the cover slip here would reduce the oxygen. So if your hemoglobin of that patient is your sickle cell hemoglobin, it becomes deoxygenated and result here the sickling process. But unlike here in your sodium dithionite test, the positive result here would not be the turbidity of your solution, but rather the presence of your abnormal morphology of the red blood cells, which is the C shape, the holy leaf, or the S shape. You read it within 1 hour. Pag negatives after 1 hour, then you try to extend up to 24 hours. And 24 hours, only after 24 hours, you would consider that one as positive or negative. Okay, then we have also here, based on your sodium metabisulfite na test, you could also classify if that one is your sickle cell disease or a trait based on the sickling process, and at the same time also on the rate and the percentage of the red cells having abnormal morphology. So pag disease, approximately 40% the red cell here would have the C or the S shape, where the sickle cell trait is only less than mga 1% lang. It is slower sickling process. Okay, the next one, we have here your hemoglobin C. Hemoglobin C is also characterized here by substitution in the beta globin chain position number 6, which is supposedly your glutamic acid being replaced here by your lysine. Yung glutamic acid is your negatively charged, lysine is positively charged. So the polymer form here with your hemoglobin C is thick and short compared with the long and thin na polymer form here with your hemoglobin S. Okay, then another one. So little here is being affected with the morphology of the red blood cells. So wala masyadong pagbabago sa shape ng red blood cells here with your hemoglobin C compared with your hemoglobin S. Where your red blood cells become CS shape. Here, hindi masyado nagiging change ang kanyang shape. And therefore, it would have your less sequestration by the spleen, and at the same time would have your less hemolytic anemia for that. Okay, and okay, this is a non-cycling hemoglobin, and consider here to be the third most common hemoglobinopathies in the world. Okay, for the crystal form here, so we have your hemoglobin SC crystals, your Washington Monument, characterized the crystal here, which try to parang leaf-like, which try to protrude here beyond the RBC membrane. So, itong RBC membrane natin, lumalabas siya dito, nag-extend. Whereas your hemoglobin CC, on the other hand, is your rod shape, your hexagonal crystal shape, and that one is not going beyond the red blood cell membrane. Okay, then we have your other hemoglobinopathies which involve here the substitution in your beta globin chain. So we have your hemoglobin C Harlem, Georgetown, characterized here by the double substitution. The first substitution, for example here, your hemoglobin S, of which your glutamic acid is being replaced at position number 6 with your valine. Another substitution occurring here at the 72 amino acid, which is your aspartic acid, being replaced by your asparagine. Another one, hemoglobin E. So that's your glutamic acid replaced here by your lysine, position number 26. Hemoglobin O, Arab, is the substitution of your glutamic acid replaced by your lysine at position number 121. Okay, then we have here your hemoglobin M. So this one involves here the substitution occurring here in your alpha, beta, the gamma globin chain, characterized by the substitution of your tyrosine with the terminal and distal histidine residue. Hemoglobin M characterized here by your methemoglobin, wherein the ion is in the ferric state, which is not your functional iron state. And your hemoglobin here would have the ferric ion that one could not bind with the oxygen, could not transport the oxygen, and therefore your tissue will be deprived with oxygen, result here to your cyanosis. And then this one with your methemoglobin, ito yung hindi siya responsive sa ating methylene blue treatment. Okay, now we have also here your thalassemia. So thalassemia, we consider it one of the quantitative defects. It's quantitative because again, it involves here the defects of the entire globin chain. The entire globin chain could either be absent or depressed. Unlike in your hemoglobinopathies here only, wherein only certain amino acid will be affected or defects. So ito ay buong globin chain ang ating affected. For the blood picture, this one is microcytic hypochromic. Then that would differentiate that one from your hemoglobinopathies, which is your normocytic normochromic. For the blood picture, peripheral blood smear would be the presence of your target cell that would signifies your thalassemia. So pag sinabi nating alpha thalassemia, so alpha globin chain is depressed or absent. Pag beta thalassemia, so beta globin chain is depressed or absent. Okay, we have here the classification of your thalassemia. First, we have here the thalassemia major. This is your beta thalassemia major. Okay, or your Colles anemia. Okay, in the beta thalassemia major, the entire beta globin chain are absent with the overproduction of the alpha globin chain. Since beta siya, so nawala lahat ng beta globin chain, dadami ang alpha globin chain. So this overproduction of your alpha globin chain, you call it was your feces body. The patient here die or do not reach the adulthood, pero nabubuhay naman siya pag pinanganak. Pero hindi lang siya naka-reach ng kanyang adulthood, namamatay pa din siya. Another one, we have your alpha thalassemia major. Okay, the alpha thalassemia major is characterized here by your hemoglobin BART. Hemoglobin BART is made up of 4 gamma globin chains. So, this is your fetal hemoglobin, 2 alpha, 2 gamma. Since wala ka nitong lahat, nawala ang alpha natin, kasi this one is alpha, what you have here, magkakaroon ka ng 4 na gamma globin chain. There is also your hemoglobin BART. Okay, then, this is characterized here by failure to thrive, hindi nabubuhay ang baby. That's your hydrops fetalis. Okay, the next one, we have your thalassemia intermedia. We have your beta thalassemia intermedia, characterized here by less severe disease manifestation, which is having hepatomegaly, splenomegaly, and that's trying to develop here later on the life of the patient. The alpha thalassemia intermedia is your hemoglobin H, that characterized here by 4 beta globin chain. So hemoglobin A1 again is 2 alpha, 2 beta. So pag wala ka nito, okay, so that would result here to the overproduction of the beta globin chain. So you have your 4 globin chain, hemoglobin H. Hemoglobin H is your Gulf hemoglobin or your repeated hemoglobin, which try to precipitate here once you're been exposed to oxidizing agent, just like your Heinz bodies. Identification of this one is by your BCB, brilliant crescent blue. Identification of that precipitate, hemoglobin H precipitate here could be found in all or throughout the cytoplasm of the cells. Pag Heinz bodies, dito lang siya sa gilid, periphery. But yung hemoglobin H could be found throughout the entire cytoplasm of your cell. Okay, another one, we have your thalassemia minima that pertains to your silent carrier patient. Kasi sabing silent carrier patients are those patients wherein they don't have your signs and symptoms. Then we have thalassemia minor, beta thalassemia minor, characterized by hemoglobin A1, hemoglobin F are both increased. Alpha thalassemia minor, characterized here by hemoglobin A1, hemoglobin F are not increased. Okay, now we go to the summary of your alpha thalassemia. So, we have silent carrier stay here, characterized by only one deletion. Pag alpha thalassemia minor, 2 genes are deleted. Pag hemoglobin H, 3 genes. And hemoglobin BART is your 4 gene deletion. Okay, for the designation of your thalassemia, so we have here beta 0, signify here that you don't have here the beta globin chain production at all. B plus, beta plus here, we have decrease in the production of your beta globin chain. The same designation for the alpha. Basta pag 0, wala. Pag B plus or my plus, mean to say you still have here the production of that particular globin chain, only that one is decreased compared to the normal production. Okay, then we have your classification of your beta thalassemia. So we have your silent carrier, wala siyang hemolytic anemia, walang signs and symptoms. Your minor would have mild hemolytic anemia, no signs and symptoms. Your major, characterized by severe hemolytic anemia, severe signs and symptoms, which is transfusion dependent. So pag sinabing transfusion dependent, the life of the patient would highly dependent on the transfusion. The patient requires to be given blood transfusion every now and then to survive. Your intermedia, on the other hand, is moderate hemolytic anemia, moderate signs symptoms, but that one is transfusion independent. Okay, so that's all with your porphyria, hemoglobinopathies, and thalassemia. Okay, thank you.